EV Expert, e-learning, diagnosis. Interlock system. Overview. The interlock is a device or system that stops system operation at certain conditions. The interlock in the electric vehicle continuously monitors the connection status of the high voltage component connectors. If there is a problem, the BMU turns off the PRA to cut off the high voltage supply. If high voltage power is supplied with a poor connection condition, a very critical situation can occur. So, interlocks will detect such situations in advance and acts like a safety device. Let's take a look at the interlock system. Interlock system. System inspection. If the high voltage cable is not connected, the circuit will be opened and the controller will detect 5 volts generated by the pull-up resistance. If the circuit is closed because high voltage cables are connected, the controller will detect 0 volts. As a result, it is possible to check firm connection of the high voltage connectors using the interlock circuit. There are 3 controllers that detect interlock circuits: BMU, MCU, and DATC. The BMU detects 4 interlock channels, the MCU detects 2 interlock channels, and the DATC detects 2 interlock channels. If a fault occurs in the interlock circuit, the BMU controls the PRA to cut the high voltage from the high voltage battery. And if the MCU or DATC detects an interlock fault, they will use CAN communication to request the BMU to cut high voltage power. Now, let's take a look at individual connectors connected to the interlock circuit. The first is 4 channels of interlock circuit detected by the BMU. Service plug, located on top of BSA. High voltage cable connector of BSA. Battery PTC heater connector of BSA. The service interlock located inside PE room. Next are 2 channels of interlock circuit detected by the MCU. One is the EPCU check cover. The other is the serial connection from the EPCU low voltage connector to the low voltage connector, DC inlet connector, cabin PTC heater connector, and high voltage battery connector of the high voltage junction block. Last are 2 channels of interlock circuit detected by the DATC. One is the high voltage cable connector and low voltage control connector of the cabin PTC heater. The other is the high voltage cable connector and low voltage control connector of the E-compressor. Now let's take a look at the DTCs for each interlock fault and countermeasures for them. Select Fault Code Searching. As the controllers that monitor interlocks are MCU, BMS, and AC controller, select all 3 of them and select OK. The MCU monitors interlock circuit of the EPCU check cover and 3 high-voltage connectors connected in series to the high-voltage junction block. Here, the MCU is normal, BMS has an issue, and the AC controller is normal. The DTC found in the BMS is P0A0812 High Voltage System Interlock Circuit. As explained earlier, there are 4 channels of interlock detected by the BMU, and the channel with trouble can be found in info code 1 of the DTC freeze frame. Then, let's check the detailed trouble information. Select Go to DTC. Select Freeze Frame. From the info code 1, number 4 is confirmed, indicating trouble in the service interlock. As such, the BMS can identify the specific trouble point using freeze frame information. However, when the DTC is found in the MCU, it is not possible to check the specific channel where the problem occurred, so it should be checked through the current data. Select Data Analysis. Select MCU from Data Analysis. Let's check the interlock voltage monitored by the MCU directly through the GDS current data. There are 2 interlock channels the MCU monitors, and if a trouble occurs, the DTC P0A0D High Voltage System Interlock Circuit High will be displayed. The voltages of the 2 channels can be checked using GDS current data, interlock sensing voltage, and cover interlock sensing voltage, and both of them are normal at 0.5 volts. Let's make a short circuit by disconnecting the low voltage connector of the high voltage junction block. At the moment of disconnection, you can see the interlock sensing voltage rising to 5 volts. Now when reconnected, it changes into normal value, 0.5 volts. This time, let's make another short circuit by removing the EPCU check cover. The cover interlock sensing voltage rises to 5 volts immediately. When reconnected, it changes into normal value, 0.5 volts. For interlock circuits monitored by the DATC, each DTC is detected on the cabin PTC heater side and the E-compressor side, so check each part according to the specific DTC.